So after the quiz, we'll do a little bit of notes and we'll do something called just mole ratio. It's real easy. And then that is what your quiz will be over on Friday, just that portion. And like I said, next Tuesday, um, we'll have a mid-unit test over stoichiometry. All right, so you can get your labs out for the quiz. Ben and Jaheen, I returned yours, so you should be able to access them again after you get through, if you'll turn them back to me, because you'll get a grade on the quiz and also a grade on doing the virtual lab. So for Ben and Jaheen, if you'll go down into quiz, I have to edit it. It says quiz virtual lab types of reactions. And it should be coming to y'all. And it is a Google Doc, so y'all should be able to type on it. All right. So if you'll look at it, let me get these handed out a little. We're missing some behind you. Oh, scares me for a minute. There you go. Pass that one over. There you go. All right. So if you look at the quiz, number 1, 2, 3, 4, 5 is for each reaction. You're going to put the type under A, the complete balanced equation under B, and a sign of a chemical reaction you saw from that particular reaction. So put them in the order that I asked. And then there's a couple of questions after that. You, Ben and Jaheen, y'all good? If I could have a thumbs up. Thank you. All righty. Y'all got 8 minutes on it. All right, so we're going to be starting on our new notes and somewhere in here. And with stoichiometry. So we're starting with kind of just the most basic thing. It's called the mole ratio. And it's needed for all stoichiometry calculations. And it's pretty easy to get. You get it from a balanced chemical equation by looking at the coefficients. So we're not leaving chemical equations behind. Now that y'all have learned that, then I expect that y'all should know that, and I'll present that at multiple times, and we're not leaving balancing equations behind. All right, so I will tell y'all stoichiometry, the key to stoichiometry is showing your work and using your units. If you don't use your units, and you aren't organized when you're with your work, then it makes it pretty hard, and it's almost impossible for me to be able to help you. My iPad has not been getting all over it lately. All right. Let's try one more time. So under stoichiometry, it should say stoichiometry is a proportional. That's your first blank. Proportional relationship between two or more substances in a chemical equation. On off and see if it decides to work. This stoichiometry relationship exists between moles, grams, volume, and atoms. And we're going to be mainly using moles and grams at this point. We talked already before when we talked about Avogadros, we talked about atoms. And we're not really going to go back to that during this part. We use stoichiometry in everyday life. Of all the things that you learn, the process that we use to do stoichiometry is called dimensional analysis, and it's actually very handy in real life. Anytime you use a recipe, if you have to cut it down or if you have to make it larger, you're using stoichiometry in a way by using the dimensional analysis. So the mole ratio is the basis for all. I'm sorry?
You're not sharing the screen.
Ben, I can't get my thing to work. That's why. Thank you for letting me know. I can't get my iPad to work. So that's why I'm just reading it out right now. But I'm trying to get it connected. I just turned it off. We're gonna see. We're gonna keep our fingers crossed. Come on. Why does it keep saying that? Please check your Wi-Fi connection. I know I have a Wi-Fi connection. That's good. So under mole ratio, it says it's the basis for all stoichiometry problems. It will always come from a balanced equation. So once again, you can't leave balancing your equation behind. Which one? Let me see. You must always this you must always. I feel like I just want to like call it a day and regroup this report. Y'all ever? Yeah, me too. All right, let's see if I can get it going here, but I'm going to do that. What am I doing? What am I doing? Just visit amongst yourselves. I'm gonna go back and fill in those ones. Don't panic, y'all. Don't panic. All right. Let's see. Let's see. All right, guys. Let's go backwards. Now, if my pen wants to work, you'll have one more possible escape. I could put it in here, but I can't ever get anything to be correct. All right, let's see. All right, we're going back, guys. Ben and Jaheen, I think I got it working. So this is supposed to be proportional relationship between two or more substances in a chemical reaction. This exists between moles, grams, which are the two that we're mainly going to be doing, volume, and atoms. So stoichiometry is the study of the amount of substances consumed and produced in a chemical reaction. And so you must always start with a balanced equation. And just because I give you an equation, don't assume it's balanced. You got to go and check that, okay? The mole ratio is the basis for all stoichiometry problems. Stuff all rattled up now. It will always come from a balanced equation. Once again, repeating that so you'll remember how important that is. A balanced equation gives you the mole relationship between substances. And your coefficients, which I think is probably misspelled here, tells you how many moles you have of something. So if you have a balanced equation, for instance, like this, we've seen this equation before to make ammonia. 3 tells me I have 3 moles of hydrogen. This 2 tells me I have 2 moles of ammonia. And since nitrogen doesn't have a coefficient, that means I have just 1 mole of nitrogen. So that part of it's pretty easy. So sometimes, and I know this is going to be frustrating for people that have a lot of number sense, because you are going to have to show your work. And at this point, you're probably going to be like, I don't need to show my work. But it is a process. The process is dimensional analysis. Today, we're just doing what I'm calling 2 steps, but we're going to get to where we're doing 4 steps, and then you'll have to show your work. So on this one, if we looked here, we said how many moles of ammonia are produced from 3 moles of hydrogen? And that's exactly what I have. I have 2 moles of ammonia being produced, and to get there, it took how many moles of hydrogen? These 3 moles of hydrogen were able to produce how many moles of ammonia? 2, right? How many moles of hydrogen react with 1 mole of nitrogen? Once again, that's exactly what I have here. Even though it's not written, we assume it's a 1. So 1 mole of nitrogen reacted with how many moles of hydrogen in this reaction? 3. It's kind of like a recipe. If you had a recipe and you needed, and let's say you were making chocolate chip cookies, and you needed one bag of chocolate chips and 1 cup of butter and 2 cups of sugar, that would be how they're related to each other. Same thing whenever we're talking about our chemical equations for chemical reactions. It's kind of just like they are recipes. All right. Move it up just a little bit. All right, sometimes it's not that easy. I can't get it directly from the equation. It's not exactly how the equation is written. So that's when I have to do a little bit of work. And you have to worry about your sig figs again. Remember, your sig figs come from your problem. So on this particular one, we're using the dimensional analysis, which is when you set up your boxes. We've used it, it's been last semester, but we've used it quite a while ago. You always start with what you're given, and I'm given that I have 2.5 moles of nitrogen. I'm going to do this up here. 2.5 moles of nitrogen. And I want to get to moles of ammonia. Remember right here, we don't put anything in this lower box. You can think of it as having a 1 in it. So at this point, if you remembered when we did this, we follow our units. Whatever my units are here, those units have to be down here. So if I moles of nitrogen there, then I have to be moles of nitrogen here. And this is when you use your mole to mole ratio. So it's going to come right here where you're going to use your mole to mole ratio simply by reading your coefficients. How many moles of nitrogen do I have? 1. And how many moles of ammonia do I have? Ammonia is my NH3. 2. So that's the mole to mole ratio of ammonia to nitrogen. And then you multiply across. 2.5 times 2 is 5. And then remember, you divide by what's there on the bottom. In this case, it's 1. So that wouldn't change it. So my answer would be 5.0 moles of ammonia. My mole ratio, which is this right here, where I'm comparing the moles of my known to the moles of my unknown, is a conversion factor. CONV is conversion if you want to write yours out. And you have to use it in all stoichiometry all stoichiometry calculations, because it's the step that moves you from your known, because in this case I had information about nitrogen, to your unknown, and my unknown in this case was my ammonia. And once again, you do have to worry about your sig figs. All right, let's look at this other one. Now we're going to be dealing with hydrogen. We're still using this balanced equation. I'm going to work mine over here because I know I'm going to run out of room. So it says if I have 6 moles of hydrogen, so that's my given. I'm going to put MOL for moles. Remember, that's the abbreviation for moles. It's not much of an abbreviation. Always start with your given, nothing here, or think of it as a 1. End at the top closest with to the equals with what you want. And in this case, I want moles of ammonia. And then I follow my units. If I'm moles of hydrogen here, I have to be moles of hydrogen down here. Anytime you're doing mole to mole, then that's always going to be your mole to mole ratio, and that's just going to come straight from your coefficients. So how many moles of hydrogen do I have in that equation? 3. And how many moles of ammonia do I have? 2. So 6 times 2 is 12. Divided by 3 is 4. Am I correct in my math? And I need 3 sig figs, so it would be 4.00 moles. We're going to learn 4 different types of problems. Mole to mole, which means my given is in moles, and what I'm trying to convert to is moles, is 2 steps. I called this the first step, and I call that the second step. Don't draw this because I'm going to erase it, but eventually we'll get to some that are 4 steps. So it kind of helps. This is the simplest problem we're going to do. It has only 1 conversion factor, which is your mole to mole ratio. So as you start learning the other ones tomorrow, it kind of helps if you remember how many steps it is. All right, let's look at another one. And now I have a different, no, still the same reaction, just on a different problem. Yes. Oh, right here. Always remember to start, balanced equation. think that's about the third time it says that on these notes. So really important to balance your equation. And like I said, just because I give you an equation, don't assume it's balanced. All right, here's my equation, nice and balanced. That little box is supposed to be an arrow, but you get the idea. Okay, it says how many moles of ammonia. So there's my ammonia, NH3, are produced when 6 moles of nitrogen react. So for what we're doing right now, we may have 3 or 4 things in the chemical reaction. We're going to only deal with 2 at a time. So in other words, I'm not worried about hydrogen. And this one, my given is ammonia. I'm sorry, my given is nitrogen and my unknown is ammonia. My given is in moles and I'm going to moles. So this is a mole to mole problem. So it's just going to be 2 steps. Always start with what you're given, which in this case is 0.600 moles of nitrogen. And I want to get to moles of ammonia. So I'm going to put that at the top closest to my equal. So that's going to be moles of ammonia. I follow my units. If I'm moles of nitrogen here, I have to be moles of nitrogen down there so they could cancel. So once you've done all that, that's kind of your hard work. Now I just need to fill my coefficients in. For my nitrogen, how many moles do I have? It doesn't have a coefficient, so what does that mean? It's just 1. Ammonia, how many moles do I have? 2. All right, we got it all filled in, so we're going to multiply across. 0.6 times 2 is 1.2. And divide it by 1 doesn't change it. I need 3 sig figs, so I would need to say 1.20 moles of ammonia. Does anybody have any questions where any of those numbers came from? Because this is the most basic thing. You got to get this before we can move on. If you were asked what the mole ratio is, so let's say if we wanted to know the mole ratio, oops, that's not how to spell mole. Nitrogen to hydrogen, you're simply using the coefficients and you're setting them up as a ratio. So for nitrogen, it would be 1. And then you would put your little dots. And for hydrogen, it would be 3. Or sometimes you see it written as 1/3. That's not a fraction. That's not a 1/3. That means for every 1 mole of nitrogen, I need 3 moles of hydrogen for this reaction. And that would want to be reduced as small as possible. So in other words, if you happen to have something that was 8/8, you would reduce that to 1/1. And there's some of those on your practice. All right, let's look at, got one more here. All right. The formation of aluminum oxide from its constituent parts. And then it gives me some information. What do I need to do first? Find the given, that would be helpful. What else do I need to do? Balance, thank you. So I feel like we've balanced this one a lot. They are supposed to be there. So I think it ends up being a 4, a 3, and a 2, if my memory serves me. Then like Karma said, my given is 2.3 moles of aluminum oxide. So that means I'm using this. And I want to know how many moles of aluminum. So that's my other one I'm interested in. I'm not worried about my oxygen in this particular one. So start with my given, 2.30 moles of aluminum oxide. Nothing under here, or you can think of it as a 1 if you feel the need to put something there. And I want to convert to moles of just plain aluminum. Follow my units. If I'm moles of aluminum oxide here, have to be the same down and diagonal so they'll cancel. So now I got everything set up. I just got to punch in some coefficients. So how many moles of aluminum oxide do I have? 2. And moles of aluminum? 4. And now we do a little bit, 2.30 times 4 and divide it by 2. I was going to say, I think I have, what do I have wrong? Or do I have it? I have it wrong on my paper too. No, I think that's right. Is this balance 4, 3, 2? And my moles of aluminum oxide in that. Yeah, no, I have it set up right. I just have it wrong. Because it asks for aluminum oxide. So if that's what I'm starting with, that's what has to be down here. 2.3 times 4 equals, and then divide it by 2. How many sig figs do I need? 3. So 4.60 moles of aluminum. Now the next one, it looks like it's a different problem, but you'll see you have some on your practice because all it does is it gives you the word problem and you've got to write it out. So it says how many moles of oxygen are produced when 4.5 moles of potassium chlorate. And you can't do this problem without giving yourself a balanced equation unless you got lucky and all of the coefficients were what? 1, exactly. But here we have potassium chlorate and it decomposes into potassium chloride plus oxygen. So this would be one that I would end up getting lucky on because all of the, oh no, I got to balance it because so I need a 3 here, a 2 here, and a 2. I would not have gotten lucky. All right, it says how many moles of oxygen, so I'm interested in oxygen, are produced when 4.50 moles of potassium chlorate are decomposed. So out of the 3 things, I'm interested in the 2 I have underlined. It's going to end up being 3 sig figs. My given is in moles. My unknown is in moles. So it's going to be a nice short one, which you'll really appreciate tomorrow when we get to doing the really long ones. So start with my given. Moles of KClO3. Nothing here, or you can think of it as a 1. And I want to convert to moles of oxygen. If I'm moles of potassium chloride, I have to do the same thing down here. So now I've done all my hard work. I just got to plug in my coefficients. So for the potassium chlorate, how many moles do I have? 2. And for my oxygen, I have 3. All right. So we're going to multiply across. This is where I'm multiplying. 4.50 times 3. And I got 13.5, and then I come back and divide by what's on the bottom. In this case, it is 2. And we said 3 sig figs, so 6.75 moles of oxygen. And that would be my answer on that one. So on y'all's practice, it starts off really easy. You're doing mole ratios, you're doing kind of like the ammonia problem, and then it gets a little bit harder, and that is what you'll see on the quiz, a little bit of everything. Y'all are going to have to do some practice at home because we're moving on tomorrow, but do your practice at home, and then if you have questions, I can answer those before we move on to our 3 and 4 step problems. All right, Ben and Jaheen, y'all do some practice at home tonight because we're gonna move on. And the next ones get to be 3 or 4 step. Did y'all turn in your lab? Also, remember to turn your lab back in so I give y'all credit for that. All right, we will see you tomorrow. All righty.